come to refraction. Look, what do you mean by refraction of light? Hello, my voice is audible?
Yes, sir.
Look, if there is no change in medium, the light travels in a straight line. Okay? In reflection we learn, na? In reflection we have covered that the motion of the light is rectilinear. Rectilinear means it move always in a straight line if the medium is the same. But what happened? Suppose this is light is coming. This is air. This is air. The first medium is air. Suppose it is now it enter into glass. It is another medium.
Yeah.
Then is light travel in a straight line? No. Look, this is happening. The incident ray is coming. It is one type of medium, that is air medium. After entering into glass medium, look, the straight line now become tilt. Again, look, they are changing the direction na. The light ray is changing the direction na. Actually, according to reflection, it should be straight. It should be straight. But when medium changes, the light ray change their path. This is nothing but our refraction of light. Okay?
Okay.
When light travels with the same transparent medium, it follows as a straight line path. If light passes in a transparent medium means the medium which allow the light to pass. But when it is coming from one medium to another medium, it changes the direction. It changes the direction. It does not remain a straight line. This is called reflection of light. Okay? Look, what do you mean by medium? Refers to any substance or material from which light can pass. Like air is a medium, air or vacuum, water is a medium, kerosene is a medium, glass is a medium, okay, paper is a medium. There are different types of a medium. So two types of medium are there. One is rare medium, one is denser medium. We have two types of medium, rare medium and a denser medium. What do you mean by rare medium? Which has a less optical density and speed of light is more in it. Okay, tell me, air is a rare medium or denser medium? Air and water are two medium. So tell me which one is rare and which one is denser. Rare means in which we have, after few seconds we will learn about refractive index. Okay, refractive index is high means it is a denser medium. Refractive index is low means it is a rare index. So leave refractive index concept. Generally think in which medium speed of light is more, that is rare. So think na, if you compare air and water, in which the speed of light is more? Air. So air is a rare medium. Okay? The medium through which speed of light is more, it is called rare medium. And denser medium means in which speed of light is lesser. Okay? Two concepts are there. Rare means speed of light high. Speed of light high. Second thing, less optical density. Less optical density. What do you mean by less than optical density? We will learn. Okay, optical density is called refractive index. Refractive index low means rare, high means denser. Two difference you have to remember. Okay? Refraction. Look, the bending of light. Reflection is the bounce back of light. Refraction is the bending of light when it travels from one medium to another. Look, now the light ray is coming. Suppose, look, this is not light ray is coming from air. This is air medium, na? This is air medium. When it enter to the liquid, when it enter to the Liquid medium, look, slightly tilted. Actually, this will be the direction, na? But it is changes the direction, na? This is called the light. Look, light bend when it goes to air to water. Air to water same, or water to air also same. Medium is changing means direction also changing. This is nothing but called reflection or refraction of light. When the bending of light when it travels from one medium to another medium is called refraction. Okay? Hello. The laws of reflection. Laws of reflection. Two rules. Same two laws are there in reflection. Here also two laws. Two law is incident ray, normal, reflected. All lie on same plane or paper. Okay, this is same. But the second one is called Snell's law. This is called Snell's law. Only you have to remember for now, until I am not teaching you Snell's law, remember this thing. The sine angle of an incident to sine angle of a refraction is always constant. Means sine of I upon sine of R is always constant. Remember this? Okay, tomorrow I will teach you Snell's law. That time you understand. Then come to look. Try to understand how refraction is happening. This is one medium. This is one medium. This is another medium. Another medium. This is the boundary. This is the boundary. Okay. Look, one incident ray is coming. Incident ray is coming. Incident ray means the ray which comes towards the surface is called incident ray. Here, point of incident means the point at which the incident ray touches the surface. Okay. According to reflection, it should be straight. It should be light should go straight. But it is look. It changes the direction. It changes the direction. Are you looking? It is slightly tilted towards the normal. This is normal, na? This is called refraction. This is called refraction. Sir, always the reflected ray will be towards the normal or away from the normal. What are you thinking?
Away from the normal.
Away from the normal. I hear that towards the normal, na? In refraction, incident ray always change the direction. Okay. If it is changing the direction, two areas are there. Either it will be away from the normal or it will towards the look. This is the normal. Means if there is no refraction, the light should be go like this. Okay. But here it is towards the normal. But some cases it will be towards the away from the normal. Let's learn in which cases it is towards the normal and in which cases away from the normal. Before this, look some term. Incident ray, the ray that strikes or fall on the surface. This is the incident ray. Okay. Point of incident, the exact point on the surface where the incident ray strikes. Look, suppose this is the surface, the exact point. It is called point of incidence. Reflected ray, the ray that changes its direction after striking the surface and travel in another direction. This is called reflected ray. This is called incident ray. This is called point of incident, and this is called reflected ray. Normal is not a ray. Okay. An imaginary line drawn perpendicular on the surface at the point of incident. Point of incident से अगर मैं एक perpendicular draw करूँगा मैं straight line, that is called normal. Okay. Angle of incidence, the angle between the incident ray and the normal. You know na, angle of reflection. You know. If you look this diagram, you understand. This is incident ray. This is reflected ray. This is point of a incidence. This is normal. This is the angle between incident ray and normal. This is the angle between reflected ray and normal. Then come to refraction when light passes from denser to rare medium. Look, two condition. Few seconds ago I was telling you two condition. One, when the reflected ray coming away from the normal means normal से दूर चला जाएगा. When it is coming closer to the normal. Tell me the two condition when it will be happening. Okay. हाँ, it is change the direction. Direction changing is two types. One is closer to normal. One is closer to normal. Another one is away from normal. Away from normal. So look the first condition. Refraction when light passes from denser to rarer medium. Denser means speed of light so slow. Speed of light slow. Rare means speed of light high. Refractive index low. In denser in low. In rare refractive index high. Okay. You look now. Suppose the light is coming. Suppose the light is this is incident ray is coming. The first medium is denser. The first medium is denser. Because look now, denser to rare medium. When light passes from denser to rare medium, although the refracted ray always away from N. Look. Here two medium are there. Medium 1 is denser. Medium 2 is rare. Denser to rare. Denser to rare means the refracted ray away from the normal. Are you looking?
Yes, sir.
Then the second one. Rare to denser. If rare to denser, then towards the normal. This condition look. Denser means suppose light is coming from glass to air. Glass to air. Glass is a denser medium. Air is a rare medium. So light will away. Sorry, refracted ray will away from N. Okay. In second condition, suppose light is coming from vacuum or air, because air is a rare medium, na? Or suppose it is trying to go liquid medium, then it is towards the normal. You understand? Denser to rarer, away. Rarer to denser, near. Then coming to reflection through a glass slab. This is important diagram. Sometime they will ask you in the exam, the final exam. Look, refraction through a glass slab. First medium here, look, in this is first medium. This is first medium, which is air. Which is air. Air means rarer. It is a rarer medium. Glass means it is a denser medium. Look, the incident ray that is coming, and here the point of incident. Look, the light is coming from rarer to denser, so the reflected ray will go near to the normal. Are you looking?
Yeah.
Then again it changing that medium, na? From first air to glass, it is changing the medium. That's why they change the direction. Again from glass to air, it should change the direction, na?
Yeah.
So listen, glass is rarer, glass is denser, air is rarer. Then this time look, it is away from the normal. It is away from the normal.
Normal.
Are you looking?
Yeah.
You have to remember, when air to glass, it is near to normal. When glass to air, it is far from the normal. So several terms related with this. O means object, okay? IR is nothing but incident ray. RR is nothing but reflected ray. ER is emergent ray. Look, two times here refraction is happening, na? So this is called emergent ray. Okay?
Okay, sir.
Then I is called angle of incidence. The angle between incident ray and the normal is called angle of incident. R1, angle of reflection. Angle of this is R1. This is R1. Okay. R2 angle of reflection at second surface में जो हो रहा है here. E is angle of emergence. Look, this is the E angle. E angle of emergent, angle of emergent ray, angle of emergent. Okay.
Okay, sir.
Here one important term is lateral displacement. Sir, what do you mean by lateral displacement? Look, lateral displacement is the perpendicular shift is the path of the incident ray when it passes through a transparent slab or medium and then emerges back into the original medium. Look, emergent ray means look, coming from incident ray coming from air na,
Yeah.
finally emergent ray going to air na. Okay. Then look, suppose there will be no change in medium, so light should travel in this way. This is the path of the light na. If there is no change in medium, the light should be straight. But reflection is happening na. So the distance between emergent ray to the perpendicular distance between incident ray and emergent ray, this is the incident ray na. The perpendicular many distance are there, but the shortest is the perpendicular means straight line. Okay, is called the lateral displacement. You understand? Suppose here is the football. But you don't know about refraction. You are sitting here to watch the object you never seen. You have to come to this position. Okay, so you have to remember lateral displacement. The lateral displacement is the perpendicular shift is the path of the incident ray when it passes through a transparent slab and then emerge back into the original medium. Otherwise you will learn this one, the perpendicular distance between incident ray and emergent ray. Okay, this is the incident ray. If there will be no medium, then this is the incident ray na, and the emergent ray, the distance between them is called the lateral displacement. You understand or not?
Understand.
Then come to what do you mean by refractive index, because here we learn na, refractive index is high, that means denser medium. Refractive index is low, that means rarer medium. And this refractive index is also called optical density. Then what do you mean by this? Remember, refractive index is nothing but the ratio between two medium, ratio between speed of a light in two medium. Understand or not? Refractive index is nothing but the ratio between speed of a light in two medium. It is denoted by n. Listen, suppose from air one incident ray is coming and going to any given medium, because always the first medium is a vacuum, means air. So n is the speed of a light in a vacuum upon speed of the light in a given medium. And you know, speed of a light in a vacuum, we know that is c, denoted by c, and whose value is 3 into 10 to the power 8 meter per second. Okay, and v is nothing but the speed of a light in given medium. In question they will give you you know the speed of light in a vacuum, they will give you in suppose another medium is water, glass, otherwise kerosene, they will give you diamond, they will give you the speed of light in this medium. You have to find the refractive index, and the refractive index formula is c upon v. Actually not c upon v, speed of light in one medium upon speed of light in another medium. Okay, and remember it is a ratio na. Refractive index is nothing but a ratio don't have any unit, it is only denoted by n. Then look here one condition. Look here, the light is coming from air, Means the first medium is air. Second medium is glass. Second medium is glass. Look,
Yes.
it is towards the normal na, because rare to denser medium. Actually, from whom you are finding refractive index? Actually, the medium where the reflected ray is going on, you are finding the refractive index of the medium in which reflected ray is going, not incident ray, Look, here I am writing
Ray.
n of w. Why I am writing n of w? Because
Huh.
now the reflected ray in water na. Look,
Yeah.
don't look in which medium incident ray is there, in which medium the reflected ray is there. You have to find a refractive index of this. N of w means refracted ray of, n is represented for refractive index, w is for water, equal to c upon, c means speed of light, because fast medium is
Yeah.
vacuum na,
Huh.
and v of w means speed of water, Acha, tell me, suppose the light ray is coming from vacuum to diamond, diamond.
Diamond.
How you have to write the refractive index? That is vacuum, that is diamond.
Huh.
How you have to write? Means for whom you are finding the refractive index? From vacuum or from diamond?
Hmm.
For vacuum you are finding the
From
refract. Hmm. Do you understand my question? In which medium the refracted ray is there? Incident ray is coming from vacuum. Refracted ray in diamond na.
Yeah.
So you have to find refractive index of a diamond, because look only the refracted ray. Refracted ray in which medium you are trying to find refractive index of those medium. Okay,
Okay, sir.
and the formula will be, it is coming from vacuum na, so c upon
Huh.
vd is nothing but vacuum of speed of light in a diamond. Okay,
Diamond.
okay, you understand or not?
Got.
Ah. Then two types of refractive index there are there. One is absolute, one is relative. One is absolute, one is relative. Look, two cases are there. One, the incident ray is coming from air, and it will be goes to any medium. If the refracted ray is coming from air or vacuum, always it is refractive index. Which type of index? Which type of refractive index it is? Absolute. Which type of absolute? Okay. If the incident ray is coming from vacuum, so it is which type of refractive index? Absolute refractive index. If the incident ray is coming from any other medium, then that is called relative index. Okay.
Okay, sir.
Then look, in this case, last page I am telling, you are finding reflected index for air or glass.
Huh.
For whom you are finding the refractive index?
Air.
Are look the reflected ray na.
Sir.
Why are you confusing? So in first image you are finding refractive index of a vacuum or glass. Look, the refracted ray is in glass, so you have to find reflected index of a glass
Huh.
in glass. Okay, formula is, it is coming from vacuum, the speed of a light in vacuum upon speed of a light in glass. Okay.
Glass. Okay, sir.
Second question I am telling. Look, suppose one ray for light of incident light is coming from, incident ray is coming from air, it goes into kerosene. Tell me, for whom you are finding the absolute for for whom you are finding the relative index. You understand my question?
Mm,
My
yes,
question
sir.
is, suppose an incident ray is coming from vacuum and the second medium is kerosene. First medium is vacuum, second medium is kerosene. Tell me it is which type of a refractive index? It is absolute refractive index or relative refractive index?
R- uh, relatives.
Look, your first medium is what? Air, na? So if first medium
Yeah.
is air, that means 100% absolute. That means 100% absolute.
You sir, you told kerosene.
Coming from air going into kerosene. So air means absolute. Okay. Then the second thing is you are finding refractive index for whom? Air or kerosene?
Air. Reflective index for the kerosene.
Kerosene, because now the look the this is the refractor ray, na? Refractor ray in kerosene. So you have to find refractive index of a kerosene. Okay. Then the formula is C upon V of a kerosene. You understand or not? You understand?
Uh, understand, sir.
Then come to okay. Last question based on this. Suppose the light is coming from vacuum or air. It is going into diamond. Then tell me it is which type of a
Yeah.
relative index? It is absolute or a relative?
Relative. It spread out.
Coming from vacuum goes into glass. It's a diamond. It is which type of a? If coming from vacuum or air, it is always absolute. Okay.
Absolute. Okay, sir.
And here you are finding absolute relative index for whom? Diamond or vacuum?
Diamond. Absolute index for the diamond.
Diamond. Because always we are finding absolute refractive index for second medium, not the first medium. Means if the first medium is vacuum, second medium is any medium, that means it is absolute refractive index. Come to relative refractive index. If the first is not air, first medium is not air, 100% that is relative refractive index. Okay. Don't look the second medium. Second medium may be air, but fast medium is not air or vacuum, that is which type of relative refractive index? This is relative refractive index. Okay. Then look, when fast look the formula. You are finding n. Here second medium is whom? Kerosene, na? Kerosene. You are finding refractive index for second medium. Always you remember, na? From this you know. But if the fast medium is vacuum, no need to write anything here. After class, no need to write anything. But if the fast medium is not air, you have to write comma water. This is the meaning refractive index of a kerosene with respect to water. Okay. If air,
Uh,
if fast medium is air, no need to write anything. If fast medium is water or other than air, you have to write. You have to write. You understand or not?
uh,
Again, I am telling. Look, here fast medium, here second medium. Fast medium,
uh,
second medium. First to know it is which type of a refractive index, look the fast medium. In this diagram, what is the fast medium?
uh,
Air or vacuum.
air. Yeah.
Air or vacuum means absolute. Here, what is the fast medium? Fast medium is what?
Air.
Are look here, I am
Air.
underlining.
Water. Water.
Water means it is not absolute, na? It is comes under relative. Okay.
Relative.
Then this you remember for knowing whether the given things is a absolute relative index or a relative relative refractive index. Then second thing, you are finding relative index for whom? For second medium. Always remember, you are finding refractive index for second medium. Okay,
Second.
you understand? Okay.
Ah.
Then look how to write the here the second medium is glass. So n glass is nothing but refractive index of a glass equal to
Refractive
he,
index of
he,
glass.
here first medium is C na. C means vacuum speed is C denoted by C, then B of a glass. You understand?
Okay, sir.
Come to here. Here the second medium is kerosene.
Kerosene.
So n of a kerosene.
Kerosene.
Here you look. First medium is what? Water. Here vacuum. If vacuum, no need to write anything here. But if other than vacuum, the first medium, you have to write comma that vacuum that medium name. Okay?
Okay, sir.
Equal to same first medium speed of a first medium upon speed of a second medium. Have you any doubt or not? Tell me.
Got it, sir. Hello, sir.
Yeah, you understand? For knowing absolute or relative, look only the first medium. If first medium is
First medium.
air that is absolute. If first medium is anything the air that is relative. And always remember you are finding a refractive index for second medium. And if it is absolute, no need to write here comma and that medium name. But if it is relative, you have to write. Okay.
Okay, sir.
Then come to
Ah.
one question based on this concept. The refractive index of a material is 1.4. If velocity of a light in vacuum is this, find the velocity of a light in material. Do you understand this question?
Ah.
What is given? Tell me.
Yes, sir.
What is the given things? Refractive index IR given n equal to how much?
Uh.
1.4.
Yes. IR 1.4.
N refractive index is denoted by n of a material n of a material is equal to 1.4. Velocity of a light in vacuum is 3.8. C equal to given 3 into 10 to the power 8. 10 to the power 8. You have to find velocity in a second medium. Velocity of a light in material. V material. Then tell me it is which type of a refractive index? Is it a relative or absolute?
It's absolute.
It's
Sir.
absolute. How you know it's absolute? Because look na, the refractive index of a metal this.
A.
If velocity of a light in vacuum is this much, already it's
A.
given, and you have to find velocity of a material. That means it's the refractive. Sorry, absolute. Absolute means n of a material. You have to write second medium. Absolute means first medium is 100% vacuum na.
Yeah.
Second medium is anything. Second medium is anything.
Anything.
So you have to find refractive index for second medium na.
Mm.
So n material equal to C upon V material. V material. Okay, n material is how much given? 1.4. How much? 1.4.
1.4.
C is how much? 3 into 10 to the power 8. And V of material don't give. You have to find. We have to find.
Fine.
Then how to find? 1.4 into V cross multiplied equal to 3 into 10 to the power 8. Okay. Then V equal to 3 into 10 to the power 8 upon 1.4. Okay.
Ah.
Then Simplify this. V equal to 3 into 10 to the power 8. Convert this 1.4 into fraction. 3 into 10 to the power 8 into 14 upon 10. If it go to this side, division become multiplication. 10 upon 14. 10 upon 14. 10 upon 14. So 3 into 10 to the power 8. 10 upon 14. 10 divided by 14. 0, 0, 10, decimal, 14 7 ja, 98, 2 0, 1 ja, 14, 6, 0, 14 14 4 ja, 56. So it is approximately 0.714. 0.714. Multiply this 0.714 into 3. So 3 4 ja 12. 3 1 ja 314. 3 7 ja 21. 0.2142 into 10 to the power 8. Okay, like this meter per second. Okay, you understand or not?
Understand.
Okay. Then come to next question. The refractive index of water. Look, you have to practice this type of question. 100% in main exam one question will come. Okay, the question based on mirror formula 1 by f equal to 1 by v plus 1 by u. This formula one question you have to practice. Based on the magnification minus b by u, one question you have to practice. And based on the refractive index you have to practice one question, at least one question. Okay, then look here.
Yes.
It is such a large question. The refractive index of water is 1.50 and the glass is 1.80. Find the refractive index of water with respect to glass and refractive index of glass with respect to water. This is the homework. Screenshot it. Put the screenshot.
Done.
Tomorrow we will complete this chapter. This is interesting chapter, na?